Everybody hang tight. We'll get started here in a few minutes. All right, good morning, everyone. Let's see, we've got 12 students here. No, 11 students. And I believe that there are 14 enrolled in the course, so almost everybody. So I put out an orientation video. I sent out an email for everybody to watch a video. Let me see, I'm going to go to our main course page in Canvas. And if you have a question during while I'm talking, you can just interrupt or feel free to use the chat. I'll try and keep my eyes on it. If you have a question or want to respond using that, that's fine. So I sent an email out that gave you a video to watch. So I'm hoping everybody had an opportunity to watch that video. If not, it's at the bottom of the first Canvas page here. You just click on that, and it's kind of just an introduction to the course. So is anybody having trouble getting into this page right here, Canvas? Everyone's okay? Okay, so here's, let me get to I don't want to go through the whole syllabus, but I do want to talk about the grades in the class. And if you look at our grades, the way I have it set up right now is basically all of your grades are your exams. Okay, so there's homework assignments I give every night, but the majority of your grade is exams. Now I'm going to change that a little bit. I've decided I'm gonna add another category here that's going to be called participation / quizzes, things like that. So I may decide from time to time to have a quiz. I also want to have people with their videos on. Okay, so I know that we all are doing Zoom. I know that you signed up to be able to be at home. but at the same time, I do need people to have their videos on. And that's just my experience over the last 2 years. Things go a lot better when I can see you. I've got 4 computer screens here in front of me. So I can look up and I can see you and I can start to associate names and faces. Now, thank you very much. Now I've got a bunch of people with their cameras on. I do not expect that every single class you will have your camera on 100% of the time. Okay, I just don't want it to be like it was when we first started, where there's 1 person, 2 people with their cameras on, and then everyone else is just kind of a mystery, just a name on a screen. Okay, so I will keep track of the video and who's got their screens on and off, and that's going to be pretty much a free part of your grade. All you got to do is show up, have your camera on, and you'll get a percentage of the grade. So I haven't decided what percent, but I think I'm going to do a 20% category for participation in quizzes. So that will reduce these down a little bit more. I'll redo it and I'll let y'all know. Next class we'll look at it, and that way you know exactly where your grade is determined. Any questions on that? All right, I got to make sure that you're in the right place. Okay, so about, I don't know how many years ago, when I was a student, which was a long time ago, there was only 1 college algebra class that you could take. It's Math 1314. Everybody who wanted a degree had to take Math 1314. And that class was hard for a lot of students because their background in math from high school was weak. And so what were happening is students were coming to college and then they couldn't actually get a degree because they couldn't get through the math requirement. So at some point, the college decided we're going to have 2 math classes, 2 college algebras. One of them is 1314, which is this class, and the other one is 1414. And the idea is that, well, let me show you a picture. Where is it? Here we go. I know that this is kind of ugly to look at here, but the idea is that, let me see if I can write on this screen. The idea is that if you wanted to go into STEM, which is science-based, you know, anything that's science, technology, okay, engineering, math, you're going to have to take the 1414 college algebra right there. That's the hard one, okay? That's the hard college algebra. And that's to prepare you for pre-calculus, calculus, and you know, whatever else you need. And then we kept the 1314 for students who were going into things like education, nursing, liberal arts. So that's this course feeds into, I need a different color here, feeds into these majors. So if you're an education, nursing, liberal arts major, you're in the right place. If you're a business major, you're not in the right place. Okay, business majors will take a class called 1324, and that feeds into business. If you're a STEM major, you're in the wrong place. Okay, so I need to make sure that you're in the right place, because the worst thing that you could do for yourself is spend an entire 16 weeks with me and then go and try and take pre-calculus and not be able to do it because, well, I mean, I'll be honest with you. I'm not here to prepare you for another math class, okay? I'm here, this is like a terminal math class. This is the end of the road math. Does that make sense? So I just have to get through the very minimum of the material that we can and still call it college algebra. And then you can go on and pursue your degree, okay? This will not be a roadblock for you. But if you are in business or STEM, it's a different standard that we hold you to. So is there anyone at this point right now that feels like you're not sure if you're in the right place? Are there any undecided majors, people who just don't know yet what they want to do? If you're undecided, again, it could be one of those things where if you change your mind, say, oh, you know what, I think I'm going to go into computer science, then you're going to have to retake this class. So my recommendation would be to do the other one. The 1414 will cover, if you take the 1414, you can do any major. It doesn't matter. All right. So what do y'all think? Everyone feel like you're in the right place? Okay, if you have a change, something come up in the next 24, 48 hours, let me know. We have a procedure to move students into a course and we'll find something for you. Okay. So I don't know. I don't know how you all feel about it, having two different math classes. You know, when I was in college, I didn't like English. I had to take English. I had to take history. And I didn't like English. I had to read a lot, write a lot. I wish they would have had like the easy English and the hard English, you know. They didn't though. I had to just do it. And so I'm not completely a huge fan of this idea of splitting it out, but I will tell you it will serve you well. Like this is going to be, let's get the math over with. All you need to do is show up and participate and put in effort, get help when you need it. And I think everyone here can succeed. All right. My history with this class is basically, you know, with the exception of one or two people who really struggle, everybody gets through. As long as you show up, you do the reviews, you do your homework, you ask questions, we'll be good. All right. Okay, questions? Everybody looks thrilled. So I know that math is probably not your favorite thing because, you know, it's the history of students, knowing the experiences that students have in high school, coming into college. I know that a lot of students struggle with math, but math is, you know, math is this big kind of like scary monster. But really, I mean, as long as you put the effort in, you will see it pay off. You know, it will pay off the more effort you put into it. So, what was your experience in high school? I mean, I know not everyone here is coming straight out of high school, but I know, like, from what I've heard in high school, the math requirements, did you have to take math as a senior? What do you, did any of you have to take math senior year? Hello, are y'all gonna help me out here? We're gonna have to talk. Look, I'm gonna call on you during class. I have a list of all your names. I'm gonna call on you. You're gonna have to talk. So may as well start now. Someone just share with me their high school experience. Raymond, you gotta say something?
Yes. Well, high school for me was a while ago. I graduated in 2011, but I believe, if I remember correctly, my last class was my senior year, and it was pre-calculus.
Okay, well, good then. I mean, that means that this should be review. I mean, it's been a long time, but it should be review, so that's good. Someone else want to share how long it's been since they've done math?
I was homeschooled.
Okay.
And I took a statistics course for my last
Okay.
math before I graduated.
Okay. Statistics, yeah. So that is an option. If you're a nursing major, if you're nursing, you can take a statistics class instead of this class, and it feeds into nursing. Just FYI.
I actually am in nursing.
Are you? Okay. So you might, I mean, it's totally up to you. I'm not trying to like get you out of here, but if you think that you just did statistics, you feel like you're comfortable with it, I could look into trying to transfer you into a statistics class, which you just might be more comfortable with. Not to say this is going to be harder. It's just that, you know, it's just might be fresher to you. Think about it. Let me know.
Okay.
Anyone else want to share their experience? How about, okay, since you're not going to share your experience, let me ask you this. Show of hands, when you were in high school taking exams and you didn't do well, show of hands, how many of you got to retake the test? Somehow they offer you some sort of retake option. Is that pretty much everyone that I'm seeing? Not everyone. So a lot of you are showing, at least half of you are saying, oh, if I didn't do well on a test, I had an opportunity to retake it. That's one of the big differences here in college, okay? Is that there's not going to be retake. There's not going to be corrections. There's not going to be this opportunity to bring your grade up, all right, in terms of the exams. So that means that the exams are going to stress you out. You're going to get freaked out and panic. And that's part of what you have to start to become better at as a student, all right, is going in knowing, okay, that this day I've got to perform, all right? And the further you go on in college, the higher the stakes become in terms of exams. I mean, I know when I was a junior and a senior in college that I would have classes where we had 2 exams, that's it, 2. Midterm final, that's it, 50% of your grade. So imagine walking into a test for an hour and 15 minutes, sitting down, and that determines half your grade. You know, so as you proceed in college, it becomes higher and higher stakes. So I don't want you going into this thinking, oh, well, if I take an exam, I'm going to be able to retake it, or I'm sure he'll offer corrections or something like that. I don't want you to go into it with that. I want you to go into it knowing, okay, when I sit down for that exam, I need to be prepared. I need to be ready. All right. I'll do everything I can to help you get ready, but that day you have to come in and do well. All right. So I will offer something in terms of the final exam. I will offer something to, like, let's say you have really one exam that's just really bad. Okay. You like all the others you do okay on, you get decent grades, but there's just one exam that really was just a bad day. I will take the whole picture, you know, look at the whole picture, your entire semester. And there is that opportunity for the final exam to replace your lowest grade. Now that's not in the syllabus because I don't want to write it down. I don't want you to go into it thinking, oh, I get a free exam. Don't think of it that way. Think of it as I want to do as well as I can. But if I have an off day, at least on one exam, I'm going to be able to have at least the final kind of help me out. Okay, I'll make that deal with everyone. But you have to show, you know, that it was just a fluke day. It can't be like you have 4 bad exams and I'm going to replace your lowest with the final. It's got to be one bad one, the rest are decent. All right, how y'all feeling? How many questions? This class almost didn't make. Do y'all know that? This class almost did not make. We had 8 students up until like the last day or 2, and then it went up to 12. I think we're up at 14 now. But I think they moved some people in here, if I'm not mistaken. They may have like taken people from other classes and put them in here. You're supposed to have 17 for a class to make, but they let it ride. So I guess you're lucky, I'm lucky. I don't know. Are we lucky? I'm not sure. We'll find out. We'll say we'll talk in 16 weeks, right? Okay. So how the course is set up, I don't want to go through this because I talk about it in the video. There is a packet that you can download, right? This packet, let me get back to it right here. There's a packet you can download. And I believe there is a way that you can get the hard copy version. You have to go on campus to get it. I've got the information for that. I'll send that out as an email. Okay, if you're interested in getting a hard copy of the packet. But I'm waiting on a couple of more details on that, but I'll get that out. We're supposed to be meeting on campus, right? I mean, we're supposed to be face-to-face. So we're, you know, hopefully we'll go back in, you know, what, February? I'm not sure when it would be. Let's see, I think it would be the 1st of February, right? Is when we would actually be on campus to meet. So we'll see how things play out. You know, I'm prepared to do Zoom the whole time if we have to. I'm prepared to go back on campus if we have to, or if we can. So we'll see. I think now, you know, for the Zoom meetings, I'm going to be here and I'm going to be recording all these sessions and I'll post them on YouTube and you can get to all this later, right? When we go to face-to-face, what I'm going to do is I'm going to set up a camera in the room and I'll record everything and I'll put it on YouTube later. I'm not going to live stream my face-to-face class. I tried that last semester. I didn't like it. because it kept me standing at a podium the whole time, and I like to move around the room. So I will record myself, but I will not, it won't be live streamed. So if for some reason you can't make it, you get COVID or something like that, you'll just have to watch the video later if we go back on campus, okay? All right, so we're gonna get down to business. We're gonna basically be working through this schedule that, again, I provide to you in here in Canvas. I'm gonna be working through this schedule, and what you're supposed to do is, follow along with this and then do some homework. And at the end of class every day, I will tell you exactly what to go do for homework. Because sometimes we won't cover everything, and I'll need you to like, oh, don't do this one, or you know what, do this. We've got further than I thought. So it'll kind of be, come to class and you'll figure out exactly what it is you need to do. The homework, you work it, you work out the questions. If you have any issues with it, you can reach out to me for help, right? I provide my cell phone number. You can text me, you can ask me questions anytime, doesn't matter. And then I have office hours, there's free tutoring. So there's a lot of resources there if you're having trouble, right? You just have to, you have to meet me halfway, all right? You have to meet me halfway. You have to put in some effort, and I'm happy to help you, but you have to reach out. I'm not gonna like send you an email and say, hey, do you need help? Hey, you need to actually meet me halfway. All right, any questions? I'm ready to go. I'm ready to start this. We're going to start with a quiz. It's not a quiz. I'm curious to see where you are with just the basic idea of fractions. So what I'm going to do, I have a problem here for you. I actually have 4 problems. Okay, I'm calling this, we're talking about fractions here. I'm calling this a pretest. It's not a test. It's not going to hurt your grade. Don't freak out. Don't start panicking already. All right. I just want to see where people are. So what I'm going to do is I have 4 questions. Okay. Here are 4 questions. 1, 2, 3, 4. And here are the questions. I want you to multiply those fractions, divide those fractions, add these fractions, subtract these fractions. And then this is a multiple choice. These are your answers. You can do choice 1, 2, 3, or 4 for the answer to this. Choice 1, 2, 3, or 4 for this. Choice 1, 2, 3, 4 for this. Choice 1, 2, 3, 4 for that. And I'm going to send out a poll right now. I'm just launching it. And I want you to take your time and I want you to answer. So I hope the poll makes sense. The poll has 4 questions. Each one has 4 options. So like, for example, if you think on question 1, the correct answer is 3, then you would click choice 3. Understand on the poll? Paper and pencil, no calculators. Okay. I know you can type these things into a calculator and get an answer. You can type in your phone and get an answer. I want to see if you can do these mechanically by hand. And I want your answers as fractions, not as decimals, as fractions. And I want you to reduce your fractions. So if you get like 2 divided by 4, you should reduce that to be 1/2 or 1/2. Let's just see where you are, okay? Let's take, well, I'll just wait for responses. And then once I get a majority of the class done, we'll talk about it again, all right? This is completely on your own. Sometimes in the future, I might put you in breakout rooms and let you all talk to each other. But for right now, this is just, let me see what you can do, all right? No stress. Everyone relax, smile. It's okay. again, I'm just going to reiterate that I really want to see if you can do this. Not, it really doesn't benefit anybody if you just go and try and use a computer or something to get the right answers. I'm not going to care if everyone in the class gets it right. I'm really more concerned about the people who get it wrong, because I want to be able to help you understand. Okay, let's just see where we are. So just to give you all an update, we've got about 6 out of 14 have responded to all 4 questions. So we'll go a little bit longer. All right, let's go 2 more minutes. Okay, I think that's everybody. Let me share the results. I think you should be able to see the results. So it looks like for the first problem, we had almost everybody that did choice 1. Number 2, it's a little more mixed. 3, a little more mixed. And 4 is kind of all over the place. So let's go through these. So what I'm going to do first today is I'm going to ask for volunteers. Instead of me just calling on you, I'm going to ask for volunteers to kind of help explain how to do the problems. All right. And if nobody volunteers, then I'll call on somebody. So does somebody want to explain to me how they got the first one? Go ahead, Raymond.
I just multiplied them together, the 8 to 5 and 3 to 3, and got 940 or 9 over 40.
Okay, so you're saying that when you have two fractions, right? Two fractions, you're saying that to multiply them, all you do is multiply straight across. You just do the 3 times the 3. And then you did the 8 times the 5, which gave you 9 over 40. Yes?
Correct.
Okay.
Yes, sir.
What do y'all think? Yes? That's the way to do it, okay? That's the way we multiply fractions. In fact, multiplying fractions is probably the easiest operation out of all the operations you can do on fractions, multiplication, because you just go straight across. So the correct answer there is the first one, okay? Good. Thank you, Raymond. Now I'm going to check you off, Raymond, as having participated today. And now I will take a volunteer for the second one. Please, not all at one time, okay? One at a time, please. So don't be afraid of getting it wrong. Look, I mean, seriously, if you say something and you're wrong, it's not like we're all going to leave here and be like, oh man, this Ashley in our class today, man, she didn't know anything. I mean, like, this is where we're going to learn. We're going to learn by making mistakes. That's the way math works. You make your mistakes, you learn, and then when the test comes, hopefully you don't make the mistakes anymore, right? So division, who wants to do 2? No. Okay, then I'm calling on somebody.
I can try.
Oh, Allison. I was going to call on you, actually. That's kind of funny. All right, Allison. So how did you do number 2?
I was a bit confused on how to do it, so I just was
Okay.
like canceling out the ones that I thought were wrong. So I
Okay.
canceled out the first one because we got that for the first answer, which was multiplying.
So it can't be that one. Okay.
And then the second one, no. And the second one is kind of like cross multiplying, so I canceled that one out.
Okay. And
And then
what about?
15, 4 just didn't. 4 didn't seem like it was right because it was like multiplying, but the bottom was like addition.
Yeah. Okay.
So I just got 3.
So you did like a process of elimination. Like, let me eliminate the ones that don't look right.
Yeah.
And go, okay. Well, and you may get the correct answer. The problem is on a test, nothing's going to be multiple choice. Everything's going to be free response. I'm only doing multiple choice because it's easy to do on a poll. But on a test, you have to understand the operation, like how to do it. So on the first one, we just multiplied straight across. So who can help everybody here by explaining how you do division of 2 fractions? There's kind of like a little technique that you have to know.
Well, you have to flip one of them and then multiply.
Yeah, you have to flip one of them. Okay, so look, you may not know this, and I will formally put this on paper in a minute. This is a pre-test. I want to see where you were. So Brandon's saying, oh, you got to flip one of them. So there's like a little phrase that you can use to help you with this. It's the phrase keep dot flip. Has anyone ever seen that before? Whenever you're doing division of 2 fractions, you do this thing called keep dot flip. So what that means is you're going to take the first fraction, 3/8, 3 over 8. You're just going to keep it, Okay, you're not gonna do anything with it. Then you're gonna change the division sign into a dot. Okay, so dot, in other words, multiplication. And then you're gonna take the second fraction and you're gonna flip it, which makes it 5/3. So you see that? I kept the first one, change this to a dot, and then flip. This is what you do whenever you're doing division. That's what you do. Division of two fractions. You keep the first one, dot it, flip it, and work it out. So now that it's multiplication, we can do what Raymond said. Multiplication, you just go straight across, right? Go straight across. So when I multiply straight across, I do the 3 times 5. I'm sorry if I sound a little congested. I'm getting over something. I'm feeling better today. So you do 8 times 3. And if I just multiply right now, I'm going to get 15 on top and 24 on the bottom. So on your exams, you are allowed to use a calculator, okay, to do things like 8 times 3. If you have trouble with like arithmetic like that, you can use your calculator, but you have to show this work, all right? So you can't just go from this, from this to the answer without anything. You've got to show some of that keep dot flip, all right? Now 15/24 is actually not correct, the correct answer, because I ask you to simplify, which means I want you to reduce the fraction if possible. And this fraction does reduce. So when I say reduce, what I mean is, can I find a number that goes into both 15 and 24? I have to think through that. Is there a number that goes into both? So can somebody tell me what number goes into both of these?
3.
3?
Yeah,
Is that what I heard? 3 goes into both. How many times does 3 go into 15?
5.
5. Okay, how many times does 3 go into 24? 8. So you can reduce the fraction to become 5/8, which means the correct answer would be 5/8. Now, 15/24 is technically not wrong in terms of it is correct, but it's not reduced. And I'm asking you to simplify, so you need to reduce it. Now, there's another way we could have got 5/8. Does anyone know how, when we were at this step, I could have got straight to 5/8? There's something I could have done here.
The 3's are opposite, so you can cancel them out because either way you're multiplying it, then you're dividing by them.
That's right. The 3 and the 3 can cancel right here. Because you have 3 on top and 3 on the bottom, you can cancel them out. And that would have left you a 5/8 right here. Same answer. So either way, you get to the same result. Are we good? Okay, so as in summary, okay, when it comes to fractions, when you multiply fractions, if you have a fraction, let's say A divided by B, it doesn't matter what it is, divided by times C divided by D, then what I'm doing is giving you a generic formula, okay? If you have a fraction times a fraction, you're gonna multiply the top across and multiply the bottom across. And that's it. That's how we multiply, straight across. When it comes to division of fractions, A over B divided by some other fraction C over D, we will keep the first one, change it to a dot, flip the second one over, and then multiply straight across. Now, you don't need to like memorize these formulas, but if you like formulas, there you go, all right? If you just want to remember it as, oh, just keep dot flip or just multiply straight across and not think of it this way, don't think of it this way, then it's fine. It's really kind of, you know, how does your brain work? What makes more sense to you? All right, multiplication, division, that's it. Now, the next operations were to add and subtract. And this is kind of an interesting thing if you think about it. When you were, you know, very young child, you know, elementary school, first grade, I don't know when it happened for you, but when you were learning numbers, right? You learned how to add and subtract first, didn't you? You learned, 5 plus 3, and then you learned subtraction. And then after you learned addition and subtraction, then you learned how to multiply and divide, right? That's the way you learned it. With fractions, we actually do multiplication and division first. And then we do addition and subtraction. And the reason we do it that way is because multiplication and division of fractions is easier than addition and subtraction. Addition and subtraction is harder. So we wait and we do it after we do the multiplication and division. So these two formulas are the easy ones. Now the addition and subtraction. So let's see. For number 3, we are kind of all over the place. Can somebody that feels comfortable share how we add fractions?
I can answer it.
Go ahead.
Okay,
Alicia?
so yeah, to add fractions, you basically for this problem, you'd have to find a common denominator,
Common denominator. Okay.
right? So to do that, what I did was multiply 8 times 5 and then 5 times 8 so that they both had the common denominator of 40. And
Okay.
then the top ones as well, multiply. Sorry, I've got a raspy throat, but the 3 on top for 3/8 times 8 as well, and then the 3 on top of the 5 multiplied by 5. Well, by 8.
Okay,
Sorry.
Good. You're doing it correctly. You're doing it correctly. So what Alicia said was she wanted to get a common denominator, right? That's what you said?
Right. A common
So-
denominator of 40 for both of them.
of 40 for both. So there's something important here that Alicia has learned and understands that I need everyone to understand. And that is when you are adding fractions or subtracting fractions, they must have the same denominators. In other words, the numbers on the bottom have to be the same in order for you to be able to add or subtract them. They have to. Now with multiplication and division, you don't need that. Okay, it's not required. But for addition and subtraction, you do. All right, you need a common denominator. So I want to take a moment to explain to you why you need this. Okay, why do you actually need this? So I'm going to try and visual. I want us to try and visualize this. Let's say that I have a candy bar, okay, and I take it and I cut it into 4 equal pieces, and I take one of those pieces. That's 1 out of 4 pieces, right? That fraction 1/4 represents how much of that candy bar I have. Understand? Yes. Now, what if I say for you then to add to that another candy bar, but instead of cutting it into 4 equal pieces, I want you to cut it into 3 equal pieces. And I want you to take one of those, or let's say 2 of them. Okay, let's say 2 of them. So that would be 2 out of 3. And so what I want you to know here is what happens when you take 1/4 of a candy bar and add 2/3 of a candy bar together. So the only way to actually do this is to do what Alicia was saying, which is to get a common denominator, which is to look at these 2 denominators and try and come up with a number that is a multiple of both. Okay, so when you think about multiples, think of the number 4. All the multiples of 4 are like 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. Those are all the multiples of 4. And then you look at the multiples of 3, 3, 6, 9, 12, 15, 18. Those are all the multiples of 3. What we're trying to find with the least common denominator, is what Alicia called it, is the smallest number that appears in both of these lists. So I'm looking for the smallest number that's in both lists, which would be a 12. And so what I need to do is figure out, is there a way to turn a 4 into a 12 and a 3 into a 12? And this is where Alicia said, what we're going to do is, let's see, we're going to multiply this 4 by a 3. So I have to do a 3 multiplied on the bottom and the top. See, because 3 divided by 3 is a 1. So I'm really multiplying something by 1, which doesn't change what it is. It's still the same number, just looks different. So if I multiply this fraction by 3/3, by 3/3, and then on this fraction multiply it by 4/4, then what happens is we get this. Remember, we just learned how to multiply, right? So we just go straight across. So 3 times 1, that gives you 3. And then 3 times 4 gives you 12. And now I'm adding that to, what does this become? Straight across. Eight over 12, right? And now I can put these together. Now, but I want you to understand why, okay? What we've done is this. Instead of saying, oh, we're taking 1 out of 4 here, instead of that, we're looking at it from a different perspective. We're saying, take that same candy bar, but instead of cutting it into 4 pieces and taking 1 of them, we want to cut it into 12 pieces and take 3 of them. So what does it mean to cut it into 12? Let me see. This was 4, right? That was 4 pieces. If I cut each one of these into 3 pieces, now I have a total of 12 pieces, right? And I'm taking 3 of them. So if I take 3 of these, 3 of the 12 is the same as taking 1 out of 4. Understand? And then over here, I take that same candy bar, I cut it into 12 pieces. So I just cut it exactly the same way. Cut it into 12 pieces, and I'm going to take 8 of them, 8 of these. So 1, 2, 3, 4, 5, 6, 7, 8 of those, and add them together. So if I take 3 of the 12 and I add 8 of the 12, how many will I have? How many pieces will I have if I add these together? These 3,
11.
I'll have how many?
11.
11. I'll have 11 out of 12, won't I? I'll have 11 out of 12. So if I add those together, I will now have 11 out of the 12 pieces. So that's what you get when you take 1/4 and you add it to 2/3. You get 11 over 12. Now, how did we do that? How do you get from here to this? All we're doing is we're taking the 3, we're adding the 8, right? And that becomes your 11. But what about the denominator? What do we do with the 12? Did we do anything to it? Did we add 12 plus 12? No, right? We left the 12 there. So that's why fractions can be tricky, is because when you're adding and subtracting, because you're really only adding the tops up or subtracting the tops. You're not touching the denominators, but you have to have a common denominator first. Okay, you have to have a common denominator first. So let's just go through this problem one more time. Let me go back to it. We had 3/8 plus 3/5. Okay, so here we go. Alicia said, let's find a common denominator. Now, how you find the common denominator is kind of like, it's going to depend on how good you are with numbers, really. So you can just look at this and be like, all right, you could list out all the multiples of 8. That would take you a while, but you could keep listing them out. Then you can list out all the multiples of 5, 10, 15, 20, 25, 30, 35, 40, 45. And again, you're looking for the smallest number that appears in both of those lists, which would be 40. And then you just use that. You just have to turn the 8 into a 40 and a 5 into a 40. So you multiply this one by 5 on top and bottom, and here 8 on top and bottom. And just remember, when you're doing that, you have to do these 2 together first, then these 2, multiply them. That's 15 over 40. And then over here, you multiply across, you get 24 over 40. Multiplying across. And then now you do the addition, which means you take this, you add that. What's that? 39? 39? Over the denominator, but you don't do anything with the denominator, you leave it as 40. Okay, questions? Does that seem familiar to you? Now that we've run through it, you get a common denominator, then add them. What's the difference? Oh, the answer then would be 1. Okay, which 7, half of you got that right. So what about the fourth one? What's the difference between the third one and the fourth one? There's only one difference, right?
You're subtracting.
Subtraction, right? So you do it the same exact way. You do your 3/8 minus your 3/5. You still have to get a common denominator, in this case of 40. So you have to multiply the first one by 5/5, this one by 8/8. Multiply the two together, these two and these two. That gives you your 15/40 minus your 24/40. And now what you're doing is you're subtracting. You're taking 15 and taking away 24. So if you have 15 and you take away 24, you will get what? You have $15, then you have to take away $24. You're going to have negative, right? -9. So you will get -9/40, which is this answer here, which 4 out of 14 of you got that one. Now, on this, I gave you these formulas, right? Is there an easy way? Is there an easy formula for addition and subtraction of fractions? Because we had to do a lot, didn't we? Like we had to do quite a bit of stuff to get to add and subtract fractions. Well, there actually is. There is a shortcut formula to do addition and subtraction of fractions. And I'm going to share that with you now. All right. So here's the way it works. When you take fractions and you add them together, let's say you take a fraction a/b plus c/d. So we're adding these two fractions. If you'd like to do a shortcut, here's the formula for it. It's a times d plus b times c all over b times d. Now, that formula looks nasty. It's like you look at it, you're like, how am I going to remember that? Well, there is a way you can remember it. All right, here's what's happening. You're taking these two numbers and multiplying them. This times this, that's AD. Do y'all see that? And then you're adding to that, because it's an addition sign, you're adding to it these two multiplied. That's this, B times C. And then you're taking these two and multiplying them, and that's these two. That's the shortcut. So let me show you on the problem that we just did, let me show you the shortcut. The problem we just did was 3/8 plus 3/8 plus 3/5. So if we do that, where is it? Come on. So as an example of this, if we do 3/8 plus 3/5, the shortcut would be first multiply these two together, right? Which would be 3 times 5, which is what? 15, right? And then I'd add to that. Now I multiply these two together. 3 and 8 is 24. And then I divide all of that by these two multiplied together, 8 times 5, which is 40. And do you all see that we arrive at the same answer? 39/40. But we never had to like go get a common denominator. Do you all see that? You are free to use this. Okay, it's totally up to you. I use it a lot. Okay, because it's very quick. There's some downside to it though. I'll show you the downside in a minute, but let me just show you. There's another formula now, last one, for subtraction. And it's the same exact formula, same exact thing, the cross thing like that, except that you're going to change this to a minus. That's the only difference. So if you have A/B minus C/D, then that's going to be A times D minus B times C all over B times D. There we go. So that's it. That's fractions. That's how you multiply, divide, add and subtract. Let's do another example of this shortcut, because I want to show you it does have some pitfalls. All right. First example I'm going to show you is going to be, oh yeah, this is great. And then the next example after that, you'll be like, yeah, I can see that that would be bad. So here's another example of it. What if I asked you to do 2/3 plus 5/6? All right, they don't have the same denominator, right? They do not. So I'd have to get a common denominator, but instead I'm gonna do the shortcut. All right. So, and I'm actually not gonna do the shortcut. I'm gonna have Sarah do the shortcut. Sarah Rivera. How's it going, Sarah?
Good.
So Sarah, where's the formula? It's right up here. So can you tell me, I'm going to add two fractions. What should my first number here be?
12.
12. Okay, so Sarah's just doing 6 times 2. Everyone good? 12 there. Good. Then
15.
plus, right? We're going to do plus.
Right.
And then 15. Good. And then over
18.
18. Okay, that's it. Now, all we have to do, does anyone have any questions on that? Sarah did 6 times 2, that's 12. Boom. Plus. And then 3 times 5, 15. Got it. 3 times 6, 18. Got it. Put it all there. Now just add up the top, right? 27 over 18. Now that is the correct answer, but it may not be reduced. So very good, Sarah. I'm going to move on to, let me see. Alicia's, I'm kind of canceling people off here that have responded. Let's see. How about Kylie? Where's Kylie? Did Kylie already play? Let's see, I have Kylie. Oh, there you are, Kylie, up in the top corner. I'm looking for you. How you doing, Kylie?
I'm good.
Good. How much of this stuff is like familiar to you?
It's pretty familiar. I was
Okay.
just a little confused. It's kind of been a while.
Yeah. Okay. So you're with us up to here? Do you like the shortcut? Do you think this will be like the preferred way instead of finding common denominators and doing all that other stuff?
Yeah, for sure.
Okay. So the only catch is that you have to make sure that this fraction is reduced, Kylie. So
Okay.
can you think of any number that goes into both of those?
3.
3? Good, right? 3 goes into 27. How many times does 3 go into 27? And look, if you have to get a calculator out, get a calculator out, right? Remember, I told you this is the non-engineering math. Okay, so if you need a calculator to do some of this arithmetic, go get your calculator. All right. So how many times would you say?
9.
9. So 3 goes in there 9 times, and then on the bottom, 3 goes into 18.
6.
6. Oh, 6 times. Okay, so that is good. Now, Kylie, can we still go though? Is there a number that goes into both of these still?
3.
3. Okay, so we go again. That's fine. 3 goes into here 3 times, and then on the bottom twice. Now we're there, right? Now we're there. Okay, we're done. That all good? All right, let's do one more. Again, to show you just how this can be pretty bad. So what if we did like 3/12? No, let me make it 5/12 plus, let's go with 1 over 240. Okay, so we're going to add these fractions. Do they have the same denominator? No, right? So we're going to have to do that little cross thing. Do you see the problem right off the top here when we do the cross thing? we're gonna have big numbers, right? That's kind of the bad thing here. Sometimes your numbers can get real big. So let me see here. Who's got a calculator out? Jose, do you have a calculator? Is Jose here? I don't see Jose. Uh-oh. All right, so this is a good way for me to take attendance too. All right, Alexis.
I have a calculator.
Okay, so first thing you're doing is what times what?
Are we doing the shortcut
Sure, do you want to do shortcut?
or we're finding the common denominators?
Let's do the shortcut first, just to illustrate how this gets real bad.
Okay, so you'll do 5 times 240
Mhm.
and that's, oh wait. 1,200.
1,200. Then we'll put a plus. Now we're gonna multiply, so we just did those two. Now we're gonna multiply those two, 12 and 1, right?
It's 12.
12, and then over, and now again, you're gonna have another big, ugly number, right? 12 times 240. You see, this is, it's gonna be a big thing. So what do you get on the bottom?
2,880.
Okay, then just add across the top, so you get 12 over 2880. Okay, and that reduces. That does reduce. There's numbers that go into those. So you'd have to start chipping away at this and reduce it down. And that could be a pain in the butt. Do y'all see that? So like as good as it is, it's got some issues that we have to be careful with. So if I were doing that, I would just start dividing by numbers I know, like 2 goes into both of those. So I just do that and then I just keep going as far as I can. Now, I'm going to leave this as go figure that out on your own. But instead, what I could have done is the first method was to find a common, least common denominator, which would have been 240. So I would have multiplied this one by 20 over 20. If I do that, I should get 240 on the bottom. Y'all following me? Instead of doing this method, if I did the first original way where you find a common denominator, then you would get on the bottom, or let's see, this across the top, you should get 100 over 240 plus 1 over 240. And now they have the same denominator, so you add across the top, you get 101 over 240. And that should already be reduced, like it can't go reduce anymore. So that fraction right here should reduce down to this. Does it make sense or no? All right, there's another thing we want to talk about before we end today. We still have another 15 minutes. And that is this whole idea of proper fraction, improper fraction, and mixed numbers. Okay, so this is going to be kind of like a review of types of fractions. So when it comes to a fraction, if you look at, I'm going to do it this way. Types of fractions. Okay, the first type of fraction is what we call a proper fraction. And a proper fraction is, here's some examples: 1/4, 2/3, 5/8, 10 over 13. These are all proper fractions. Let me show you improper. And if I show you improper, you'll maybe be able to tell the difference. 4/3, 15 over 12, 7/5, 12/5. Can you all see the difference between a proper and improper fraction? Can someone explain it to me? Maybe Corwin? Is Corwin here?
I'm here. It's just the numerator is bigger than the denominator.
On the impropers, right? On these impropers, notice all of these numerators, the numerator is the top of the fraction, are bigger than the denominators, aren't they? And with the proper fraction, it's the other way around. The bigger is on the bottom. Do y'all see that? That's the difference between a proper fraction and improper fraction. So whenever we have fractions, they're either going to be proper or improper. Now, the reason this is important is because when you have an improper fraction, there's another way you can write it. We can write this. We can write it as what's called a mixed number. So let me show you, I'm going to pick one of these. Let me pick 12/5. Let me show you how we can write this as a mixed number. See if this looks familiar to you. What we do is we break out the old school division. We put 12 here and we put 5 here. Remember this old school? We call this long division. Take the 12 divided by 5. So if I take 12 divided by 5, I say, okay, what do I multiply 5 by to get 12 without going over 12? So I have to put a 2 here, right? Because 2 times 5 is 10. I put the 10 under here. I subtract, I'm left with 2. And then that's my remainder, right? That's how much is left because 5 doesn't go into 2. Now I'm not going to do decimals here. I'm going to see if this rings a bell. What you do now is you take this and you convert this into the answer, which would be 2. That's this number here. Then you put the remainder, 2, divided by whatever the divisor was, 5. This is the mixed number that represents this fraction. These two are equivalent. One of them is called the improper fraction. The other one is called the mixed number. But they're the same exact thing. Now, mixed numbers are used a lot in elementary school, grade school math, but the further you go in math, we stop using mixed numbers. In this class, we will continue to use them, but I'm just letting you know, like, if this were the 1414 class, we wouldn't even look at mixed numbers. They're too childish in a way. We just don't work with them that much in higher level math. We work with the improper fractions instead. So in this class, what I need to make sure you know how to do is how to take an improper and turn it into a mixed number. And I also need to make sure you know how to go back and do it the other way. So to turn improper into mixed, you do the old school division. How do you turn the mixed into the improper? How do you go backwards from right to left? You know, and remember how to do it? There's kind of like a little technique. If you have 2 2/5, how do you turn that into improper? Anyone remember? Cambry? Is Cambry here?
Do you multiply the bigger number by the denominator?
Okay, so you take this number and you multiply them. Yes? Is that what you're saying? Okay, so I'm going to take that and multiply that. So I'm going to take 2 times 5, and then what? That's 10. And then what do I do with that?
Add it to the numerator.
You add that, you add the 2 to it. So you add the 2 to it. And so 2 times 5 is 10, you add 2, that gives you 12. And then what do you do with that 12?
Put it over the 5.
Yeah, divided by the 5 that's here. So we take that 5 and we put it underneath. And there's how you get back to the improper. Let me do another one. I know a lot of you have seen this, it's just been a long time. What if we have 3 1/4? If I wanted that to be an improper fraction, I would do, let's get through everyone today. Keegan, are you here? Keegan, yeah, Keegan participated, I think, earlier, but Keegan, can you kind of walk me through how to do this?
Yep.
Okay,
So you'd multiply the 3 by the denominator,
okay, which would be
4, and it would
Okay,
be
so
12.
12. So 3 times 4 is 12. Then what?
You'd take the sum of that and add it to the numerator, or the 1.
Add to 1. So you have 12, 3 times 4 is 12. You add 1, you get 13.
Yep.
And then you divide that by what?
4.
By 4. And that's it. That's your improper fraction. Okay. So it's hard for me to write those steps down. Do y'all agree? Like, to write that out in words would be kind of hard to explain. So you just have to understand it's like a pattern, right? You're taking this, you're multiplying that. After that, you're adding this. It's kind of weird. And then after you add that, you divide by the 4. It's just weird, but that's the short way to do it. It's very efficient. Okay, let's talk about homework. So in this packet, page 221, all right, and I'll write this down so everyone has it. Page 221 in the packet. This is the homework on fractions. Y'all see that? Homework on fractions. I want y'all to do, let me just look at this here. You should do 1 through 16. Now, at a bare minimum, do the odds, okay? 1, 3, 5, 7, 9, do the odds. Now, if you want more practice, do the evens as well, all right? And then what I'd like for you to do is I'd like for you, after you do that, to at least try number 19 and 20. Now, oh, whoa, what happens? Hold on a second. I accidentally deleted all that. Okay. So try number 19 and 20. Now, those are word problems. We have not done any word problems. So we'll see how that goes. And I anticipate you may have some questions. All right. I will give you a hint on these problems. Like, look at number 2. It's asking you to add these 2 fractions together, right? Add those 2, but they're mixed numbers, aren't they? We didn't learn a way of adding mixed numbers together. So the first step is to change this to an improper, right? Which is what Keegan was just walking through with us and showing us, okay, you take the 5 multiplied times 8 and then add the 3. So create the improper fractions first. And then after you do improper, then add. Okay, so when you add, you can either do the common denominator or the shortcut. So just be careful because, we did a lot of this in class today, like this stuff. We did all those, but we didn't really do anything like this yet. All right, so you'll find this in the homework as we're working through the class that, not every single problem in the homework is going to be something you can look back in the lecture and be like, oh yeah, we did that problem. But if you understand the concepts, you should be able to do them. And let's just see how it goes. All right. Remember, I am changing your grading scheme. A 20% of your grade is now going to be participation, cameras on like this. Very good. And then also potential like quizzes. So it may be that when we come into class next time, I put up a problem like something from the homework like this. Maybe I give you a problem similar to that to start class as a poll, and you have to do multiple choice and choose the right answer and count that as a quiz grade. Okay, so just in other words, be prepared next class. Cover this material, make sure you understand it. If you don't understand it, contact me before class. Come to my office hours, text me, email me, say, hey, I'm having trouble. Go to tutoring, but be prepared for the next class. Questions? Okay, thank you all for your participation and your cameras and everything else, and see how this goes over the next week or two, and maybe we'll be face-to-face soon. I'll hang out for a minute if you have any questions. Oh, let me say one more thing. I'm sorry. Hold on. When we do go back on campus, if we do, I have another class that starts at 1 after this class, but it's a Zoom class. which means I have to drive home to do the Zoom. I can't Zoom from my office because it's an office, it's not made for Zooming in there. So I'm at home here, I've got everything set up properly. So that means that when we do face-to-face classes at 12:15, I will be leaving class, getting in my car and driving home so I can be ready for my 1 o'clock class. So I just want y'all to know that. That's why I don't have any office hours right after class. It's because there's this transition period where I have to go somewhere. So just letting y'all know that ahead of time. Okay, everyone, have a great day. We'll see you on Thursday.
Bye, thank you.
Bye.
Thank you.
Have a good day, sir.
Yep,
Thank you.
hang out if you have any questions. All right.